For this question, we have to get unit vectors, and unit vectors, we always have to know the unit vector is a 1. No matter whatever vector we have, unit vector has to always be 1. So I'm going to use a components. I'm going to have 4 and 3. For x hat, let's say x actually goes up. Let's make this interesting. 3 y hat goes towards the right, and z hat is 0. That comes off the board, so that's the Cartesian coordinate system. That has all to be perpendicular. Vector A is going to be 4x components plus 3x y components plus z components. So that's our vector. But now if you want to find the magnitude, it's going to be 4 square, 3 square plus z plus 0 square, because that's z. We don't have any z. It's going to be 16.9 to get the magnitude. Remember, the magnitude of a vector through its components is that we get the square root of raising all the components to the power of 2. So we get square root of 25, which is 5, and that's our magnitude. Again, the relationship is that we all have scalar. Magnitudes give us scalar. Unit vector is going to give us scalar, so 5 over 1 is 5, and that's what we give for the answer. This is a unit vector because we have 1. When you have a unit vector, so that's 1. That's how we get a unit vector, so this is a unit vector. Y hat. And we always remember this are our components. So we have a vector B, and we have 2 y hats and 20.5 x hat again, y, x, z. Z is going to be 0 because it's coming out of the board, and we have perpendicular, so one of them has to be 0. You have 2.5 x hats component, 2 y hats, and 0 z hats. And now you're going to have all of them addition together, raised to the power of 2, and square root of all of them, which you get 5 plus 4. You go square root of 9, which is 3. But again, remember the relationship is whatever magnitude that we get for the vector, the unit vector always has to be 1, and this has to be 1. So just like in this one, this is a unit vector. And this is our second one that we can get. Unfortunately, for the next two ones that we have on our list, none of them can be a unit vector. And that is because we have y hat plus z hat over square root of 2, and then we have x hat plus y hat plus z hat over square root of 3, because that is not going to give us something that we need. It's going to be a fraction, and it's not also going to give us something that's going to be unit vector, because this produces not really a scalar, because we have the components and we have nothing else to do with this. But we had components, so we could get the magnitude. Over here we cannot get the magnitude, so you cannot get a unit vector. So these are not a unit vector, the a and b are. So you're going to get the magnitude between those vectors, and I'm going to show it to you in a couple of minutes. So now I have a and b, and we have the magnitude of 5 and 3 that we got. And as I draw, I see a 10 degrees angle. So I'm going to put cosine of 30 degrees, and we're going to calculate that with the calculator. We get 40.77, which has to be positive, because it has to be positive because it's not cute. And you remember that how we can do that. So we get from the components, and then we get the dot product, because we had the magnitude that we got from the components to add this to the dot product. So that's how we get that. And you finish up this, you have two unit vectors, or these two, and then that's how we get the dot product between two vectors. And hopefully you guys learn. If you have any questions, just let me know in the comments, and I'll get back to them.